Hello, everyone. Thank you for coming back after lunch. I hope you're feeling rested. We are going to talk to you a bit about data science and what it is. Before we do, I just want to introduce who we are. So I'm Giselle. You might have heard from me this morning if you've been with us for a little while. I'm the Executive Director of Data4Kind UK and one of your festival hosts today. And I have with me Dulcie, our Data Science Lead at Data4Kind UK, who will be chatting to you about data science in a moment. Before we get stuck in, a few words about this Data4Kind UK organisation I've been mentioning. So we are a charity that helps other charities use data, in particular use data science. Thus talking about our USB today. We do that for free with any social change organisation, whether a charity, a social enterprise, a public sector body. And the reason we can wrangle that is partly because we're grant funded and partly because we do all our work through an amazing pro bono network of data scientists who come to support us from their day jobs in consultancies or in industry. So we offer a few different types of projects. Some of them are exploratory, so a couple of months of work to help an organisation figure out what are the gems contained in its data, what questions does it want answered about its services or its organisation. And sometimes we do much longer projects that might be a year long, where instead we'll help an organisation what we call deploy a model, for example. So create a data science product. It might be, for example, predicting risk levels among clients or beneficiaries, and we'll help them create that so it's something they can use every day to inform their work and their decisions that their staff are taking. We also have some very light touch support we call office hours. So if you do think to yourself, I don't need the big project, or I don't know if I do, but I'm just blocked on one thing. You know, it's whether you're a technical person and you're blocked on one bit of code or a particular chart or bit of analysis you're trying to do, or whether you're a kind of strategic or team lead or exec level person who says, actually, I don't need technical support, so I'm not doing that work, but I would really love some support on data strategy or helping understand where our organisation can go with this data stuff, then we can help you on that as well. So look us up online, pop into the booth if you want a bit of support. If there's anything immediate we can help with, we will as well over the couple of days we're here at the festival. So that's a bit about us. Because we've been doing this work for a little while with charities, helping them use data and data science, we've got used to kind of talking about what this data science stuff is and why it's relevant to organisations. So that's what we thought we'd do today for about 40 minutes or so, and then we are going to move into Q&A. So please, if you do have questions that come up, please do put them in the Q&A as we go, and we'll save them up to respond to at the end. But for now, I am going to stop talking. You've heard enough from me, and hand over to Dulcie to give you our Data Science 101.
Thanks, Giselle. Yes, we thought it would be remiss to not have a what is data science at a Data4Good festival. So hopefully we can shed a bit of light on that today. We'll also talk a bit about what is data even, which is a question that came up in one of the sessions this morning. I'm not sure if we have the ground truth on that, but we'll offer at least some sort of definition. Let's talk about what is data, then what is data science. But then probably most importantly, how could it be applied usefully in your organization or in social change organizations? We'll end with a few tips for how you can get started, but I'll say that we'll go into this in a bit more depth on Wednesday in a talk about what the role of data science is in the social sector. Along the way, I'm also going to try and demystify some jargon. I will do my best not to actually use any jargon without defining it, but feel free to call me out if I have, and in the chat or the Q&A, and we'll do our best to kind of clarify buzzwords for you. Like any field, there's common language, and you just have to kind of learn the language of the field, and don't be intimidated. It's just another set of words from a different domain. Okay, so before we do that though, I just wanted to get a sense of who's here. So we're gonna do two polls. The first one, just asking, what type of organization do you work in? Are you coming from a frontline service delivery charity? Are you perhaps a support organization? Maybe you're a capacity builder like DataKind, or you're a funder or an infrastructure CVS type organization. Are you here from a social enterprise? Are you here from a smaller group like a community or mutual aid group? Are you working in local government, or something else that we've missed altogether? And if you are in that other group, please do say in the chat who you're here representing. So I think the poll, yep, the poll should be open, great. And then there's a second question as well around what's your confidence with data? So we get questions across the whole scale. Every organization, including DataKind, is on a journey with data. So just curious to get a sense of this audience's relative kind of data maturity. So are you just starting out? Are you, you feel like you can do the basics, you can do some impact reporting? Good, this is maybe you're a data analyst, maybe reporting and analysis is your bread and butter, or super, like you use data science all the time and you should maybe be giving this talk instead. And don't be shy to put that if that is indeed you. So give people a second to fill in those polls. And yes, the poll is in the, if you click on stage and then you click on polls, there should be a poll. And if you vote, you should be able to see the percentages. Excellent. Looks like things are coming in. I'm just going to give folks a minute to find that bit of the hop-in user experience piece. I think this has been a crash course for all of us in learning this new technology. It looks like we've got so far a lot of frontline service delivery charities, about 40% of the folks who are here, which is not wildly surprising. We work with a lot of service delivery organizations, but also a lot of infrastructure organizations or funders, which is great. And I know that there's a couple sessions on just for funders over the course of the next few days. Other represents nearly 20% of the group here. So if that's you, please do tell us who you are, where you're from, in the chat. I'll see if anyone's done that. And in terms of where you're at with data, a real mixture, but it looks like the majority are in the good territory. I do reporting and analysis routinely. So we're going to start kind of from basics. If you do have some more complex questions, please don't hesitate to throw them in the Q&A. We'll do our best to answer those as well. But we didn't want to make any assumptions. So hopefully there'll be something in here for everyone. And it looks like we've also got some folks who are just starting out, which is great, and some people who use data science all the time. So I will caveat some of the things in this talk to say that, people have different opinions about what is and what isn't data science. This is one opinion. And I'm would always love to have a discussion about differing views. All right, so that's great. Let's get started then. So first, what is data? I think this came up in the discussion right at the beginning of the day, our keynote. What is data? Data definitely seems to be kind of everywhere. Broadly, when I think of data, I think of any kind of information that's collected and recorded, often through some sort of observation. Perhaps the most common type of data in your world, if you're doing reporting and analysis, is numeric data that's kind of organized and collected in a spreadsheet. Maybe this is data about your clients or users. Here we have some population percentages by ward. Maybe you're collecting demographic data or other characteristics about your clients. Data might include survey data about people's preferences, what they like or what they don't like. You might also have data on outcomes, what's maybe changed as the result of using a service. There's, of course, lots of geographical data or other observed data. Here's just a map of the UK, showing data around the different types of land cover. Obviously, lots of geographical data out there. But data isn't just kept in spreadsheets and forms. Data can also include images and videos. For example, medical images or facial information can be used as data. Behavioral data is also really important. I don't know if anybody saw this throughout the pandemic, but Google and others, I think this is Apple, were releasing data around pedestrian activity. So we all have, not all of us, but a lot of us have smartphones, and a lot of us share some of that location data. And so this looked at how active pedestrians were in London throughout different parts of lockdown. There's also, of course, behavioral data from social media. So what you click on a website, that can be useful data. Social media likes, Twitter likes, all data. And then messages and text is also data. So messages in a web chat, or as some of you might have heard in the talk from the London funders earlier, grant applications, all of that text data can also be used as data. And this gets us to kind of a useful distinction. So there's lots of different ways of describing or categorizing data. And one of those ways is whether data is structured or unstructured. This might be a term that you've heard people use. This can be a kind of useful or informative distinction because it can actually affect how you manipulate, store, analyze, or actually get any meaning from the data. So structured data is definitely, I think, what most people are most used to. So this might be quantitative data, numbers, values that you can easily search. So you might have a spreadsheet with your clients, and then their attendance rates or how much money they've donated to your campaign, or maybe their demographic details, nicely organized. You can search it. That would be structured data. Unstructured data is not nicely searchable like this. It's not stored in nice rows and columns. It's not even organized in a predefined way, as per the name. Often unstructured data contains a lot of text, and because of this, it can be more difficult to store and analyze. So I would say that either way, whether you've got structured data, unstructured data, for a data analyst or data scientist, data is almost always messy, and you usually spend kind of 80–90% of the time cleaning up data or joining multiple data sets together. So if that is you, you are not alone. That is common. So if that is data, or at least one way of thinking about data, what is data science? So data science is a relatively new term, I think maybe 50–60 years old, but using data itself to gain actionable insights is far from new. And this is by no means the oldest example, but it's a map that might be familiar to some folks from the mid-1800s. So as some people might know, there was a cholera outbreak in Soho in the mid-1800s, and John Snow was interested in understanding where these cholera deaths were happening. And so during this outbreak, he mapped the location of the deaths alongside the location of the water pumps. And he noticed that the areas with the highest deaths, which are shown by these little black bars, so each line unfortunately representing a life lost, happened to be closest to the water pumps. And so he had a hunch, therefore, that there was a contaminated water pump leading to this cholera outbreak. And these maps actually led to the pump handles being removed and lives being saved. So we've been using data for hundreds of years to try and make decisions. But a common kind of definition of data science, not the only definition, but a common one, is the use of analytical and computational techniques to get meaning, insights from novel data sources, usually for the sake of supporting organizational decision-making. And I would say that unlike 200 years ago, one of the key differences and what makes data science a really exciting field is that computers enable us to analyze such large volumes of data in a quite sophisticated way. But I would say that even though we have these computers that can really help us answer questions and analyze types of data that would be really difficult to analyze manually, it's still the most important tool in a data scientist toolbox is to understand the context of the data that you're working with and to ask good questions. At DataKind, we're never looking for a good question within a data set. We always start looking for good we always start looking for good questions before looking for data and trying to dig out a question from that data set. So I wanted to give you a few examples of data science kind of in the wild. I think you probably have interacted with tools using machine learning algorithms multiple times in the last 24 hours, perhaps without realizing it. So this is possibly revealing, but data science is used all the time to predict behavior. So Amazon Prime, Netflix, all those websites that you go for your Friday night entertainment, look at the historical data of what you've watched, and then try to recommend things that they predict that you're going to like in the future. So data science can be a very useful tool to predict user behavior in the future. It may or may not be accurate. Data science is also used for things like fraud detection. So one of the big things you can do with data science is detect patterns. And then with that, you can detect things that divert or are different from those patterns. So I suspect many of you here have had a payment declined because the pattern of spending appeared to your bank to not fit your historical spending behavior. And so data science can be really useful for understanding trends and detecting kind of anomalies or outliers. Data science is also used to classify things as, for example, spam or not spam. So when you receive, that email from I'm always getting ones from the HMRC, but not really, saying that I'm owed some sort of tax refund, which I'm not. So there's algorithms, Google, Gmail, et cetera, use algorithms to determine whether those emails are spam or not spam. And that requires the use of machine learning algorithms. We'll go into what machine learning is in a bit as well. Data science is also used for speech recognition. So when you ask Siri or Google Assistant or your Alexa device or Google Home thing, your speech has to be translated into text. And Siri doesn't have a kind of repository of all of the sentences that have ever existed in the world. That has to be able to recognize new sentences and find relevant content for those sentences. So again, data science is used here. Used for Google searching. If you're scanning the web for content, Google will present you with the pages it thinks are most relevant to your search. And then for facial recognition or image recognition, data science can be used to detect or identify faces, which is quite complicated because, a face has to be recognized in multiple angles and multiple types of lighting or in crowds. And some people might have seen that controversially, the Met Police have been using facial recognition to recognize people on different watch lists. Hopefully this isn't something that folks have been encountering a lot lately. Lastly, data science can be useful for route optimization. So, a lot of people have been getting tons of orders during lockdown, food delivery, Amazon deliveries, and all of that requires optimization of the route planning so that the poor delivery people don't end up going backwards and forwards across the UK. So those are kind of a few examples of data science in real life. I just wanted to break down next some common data science approaches. So often you'll hear in data science three kind of types of analytics. So descriptive analytics, predictive analytics, and prescriptive analytics. What does that even mean? So descriptive analytics is perhaps what you're most comfortable doing with impact and measuring and evaluation reporting and that sort of thing. So descriptive analytics tells you what has happened in the past, tells you what's happened or what is maybe currently happening. So it's looking at your historical data. Predictive analytics is using that historical data to try to predict or forecast what might happen in the future. So this can be helpful for kind of anticipating your future needs or anticipating user behavior. Prescriptive analytics goes a little bit further and tries to save time or optimize things by suggesting next steps. So once you know what might happen in the future, what should you do? Or what would the implication of different decisions be on outcomes? Or if you know the outcome that you want to get, what kind of changes can you make that will help you get to that desired outcome? So I'll give you a bit more of a concrete example of these. So to explain the difference between these three different approaches, I just wanted to show you some COVID data. This is from Canada, not just because I'm Canadian, but because the UK is doing so well that the graphs didn't look quite as good, whereas Canada is not in great shape at the moment. But this is sadly the Canadian COVID daily deaths, the vertical axis showing us the daily deaths from COVID, and then horizontally looking across time. And the red lines are showing us historical data. So it's showing us the number of people who died from COVID over this period of time. And it's descriptive because it's telling us what has already happened. If we look to the future with this purple dotted line after the today bar, this is a model that this is data from a model that predicts what's likely to happen. So based on this historical pattern of COVID deaths, data science models can be used to predict future daily deaths if things were to kind of continue as they are. And so predictive analytics try to answer the question, what will happen? And then prescriptive analytics is asking the question, what should we do to make our goal happen, or what might happen in different scenarios? So you might imagine that a public health agency would be trying to encourage folks to adopt behaviors to minimize deaths. And so this green line here is telling us the projected deaths if everybody used masks 100% of the time. So you can see that there's not a striking, but a little bit of an impact, a little bit of a reduction in daily deaths. And so predictive analytics allow you to explore the implications of different courses of action. So how can these approaches be used, particularly within the social sector? Super great that Netflix can tell me what to watch next. I'm not going to minimize the importance of that in my life, but how can this be useful to the social sector? I'm going to talk about 5 different ways about how data science can broadly be useful. So detecting patterns or trends and violations of those patterns. So the fraud example, predicting behavior. So not just what you'll watch on Netflix or what is the most relevant website for you on Google, but which of your clients are most likely to drop out of school or something. Testing assumptions or hypotheses. So testing your hunch about why something happened. Classifying things. This is a bit vague, but data science can be really useful for trying to classify things as one of many categories. So we'll talk a little bit about that. And then optimizing resources. So certainly data science is useful in the logistics industry to optimize truck delivery routes, but how can it be useful for you? So the first example I want to talk about is around detecting patterns. And this is an example from the London funders, who some of you would have heard from this morning. And they wanted to understand the needs of their grantees and the communities that those grantees serve. So as those of you would have heard from Grace and Geraldine, who did a great session this morning, the London funders were offering the London Community Response Fund to London charities, and some of their initial grants were focused on food. But they had a suspicion that there were other needs, and fortuitously, they had asked the applicants to this fund, how has COVID impacted the community that you serve? Unfortunately, they had hundreds of applications. And so I know for me, reading through 300 applications and trying to synthesize like what are the common needs from our applicants would be very, very difficult. So instead, what they did was look at the text of those applications and see if they could pick out common words or themes. So this is just a word cloud. Some of you might have seen this kind of visualization before. And it looks at common word pairs. So two words that occur together and the size reflecting the number of times the word pair appears. So what was really striking was that even though the grant applications were not about mental health per se, I think they actually focused more on food and food security. Mental health was by far the most frequent keyword pair that came out. But this analysis also identified common issues around domestic violence, around universal credit, around specific communities being affected, such as the BAME community and key workers. And so this helped tell them a little bit more about what the needs of their communities were, and even informed some of their future funding. In terms of predicting behavior, this example is actually from a DataKind project done from a different DataKind chapter in California. So here, the organization wanted to understand whether they could predict water demand. So the Molten Nigel Water District is in Southern California, and they've been suffering a lot of droughts in recent years. And they wanted to know, can we more precisely and accurately forecast water demand so that we can have better pricing, we can have better conservation programs, and we can, more efficiently transport water through our network. So with this, the team worked to create a dashboard to predict water demand. So you don't need to worry about the majority of the dashboard, but basically the team created a tool where the water analysts could look and see whether there was a risk of the projected water use exceeding the maximum capacity. So the red line is the maximum supply that they could possibly do, and then the blue line is the forecasted demand, with the dotted line being, I think, today. So looking into the future, in this case, there was not a huge risk of them exceeding demand, but this would allow them to better manage their future resources and make sure that they could reduce usage if they were about to hit that capacity. And I would say that predictive analytics can be really useful for the social sector, not just sort of forecasting things like water demand, but forecasting. I think that there's going to be a talk by Afua Bruce either tomorrow or the next day about predicting student dropout rates. We've certainly worked with organizations in the past who try to predict which clients might be at risk of worse outcomes so that they can offer them additional support earlier in their journey. So this can be a really fruitful approach. So the third way that data science, I think, can be really helpful is testing assumptions. So this was a recent project that we did with Citizens Advice Lewisham, and they rather sweetly had this sort of fear that perhaps they were not serving the most vulnerable members of their community. So Citizens Advice Lewisham are one of the citizens advice bureaus, and they work with within the borough of Lewisham to provide advice and support on many different issues. And they were just a bit worried that maybe they weren't meeting the most vulnerable people in their community. And so a sort of quick sanity check of that was to look at where their clients were coming from and where the areas of the borough were with the highest levels of deprivation. So this, of course, is just one definition of vulnerability. But what Citizens Advice Lewisham did here was use open data on the indices of multiple deprivation. And this is a government metric that captures 7 different areas of deprivation, from income, employment, health, crime. And they made these quite pretty maps, I think. So on the left is the map of multiple deprivation in each of the sort of sub areas of Lewisham. The red areas are those that are the least deprived overall, and the yellow areas are those that were the most deprived. So, for example, down in the south of the borough and near Beckenham Place Park, that was some of the areas with higher levels of deprivation, where, you know, along the edges up near Telegraph Hill or Blackheath, those areas were relatively less deprived. So that's what the map looked like for deprivation. And they wanted to compare that to where their clients were coming from. So they made a similar map looking at the total cases per capita. So controlling for the population in each of those areas coming into Citizens Advice Lewisham's services. So again, the colors correspond to the volume. So the yellow areas were those areas where Cal was getting the most clients, and the purpley red areas were getting the least. And happily, the maps, at least visually, line up quite well. So in this sort of south area of the borough, that's where they're getting a high proportion of their clients. And that's also where the population with the highest deprivation scores tends to be. So this was quite helpful for them to reassure them that they were reaching those clients who need them, and was helpful for them to advocate for funding to secure their ability to do that in the future. So I want to turn now and talk about a project we weren't involved in at all, but that I thought was interesting, by Visit England, who are the National Tourist Board for England, and who I'm curious what they've been up to. It must have been a stressful year for tourism boards. But this is a project that they did a while back, asking whether they could segment their users into meaningful groups. So this is an example of how data science can be used to classify things into one of many categories. So Visit England wanted to know whether the people, the tourists who use their services could be segmented into different groups. So not just based on single demographics like their age, but also based on what they like to do, whether there are people who like to go canyoning in Scotland, for example. I guess that wouldn't be in Visit England, but canyoning, let's say, or whether there are people who like to go and have a cocktail on the beach. Could be the same person, we don't know. And what are their motivations and needs? Are they somebody who really wants to be close to food shops? Or are they people who are traveling with families and they don't want to spend 4 hours on driving? And so they looked at a whole bunch of different features about their users and found that combining these features allowed to them to split their audience into 5 different segments. So by far the largest audience was the so-called country-loving traditionalists. So they found that about 30% of their audience were these empty nesters who were into countryside breaks, who valued secure accommodation, good quality, that sort of thing. Whereas a smaller proportion of the people visiting their website and services were interested in this kind of family fun. So London-based families with children at home taking short breaks. And this mattered for them because they wanted to use the information to target their marketing and messaging. So some of these groups would be more or less engaged with social media. They had different kind of needs. And so by classifying the users into different groups, they could target their messaging appropriately. So then lastly, I just wanted to talk about some work from Christians Against Poverty. I hope lots of you saw Martin's really inspirational, I think, talk this morning. It was great. And if you didn't get a chance to see it, I definitely check out the recording. So Christians Against Poverty aim to get folks out of poverty. And they do this by providing debt counseling services. And when a person first interacts with Christians Against Poverty, they have to give the debt advisor and debt coaches lots of information. So they might have to give them information about their total debt, lots of information about their family circumstances. Do they have children? What benefits are they receiving? And that sort of thing. And based on this intake information, the Christians Against Poverty advisors can then recommend a route for the client. And that route out of debt might be something like a payment plan. It might be they might recommend insolvency, or they might recommend a kind of holding route. So to wait and see if circumstances are likely to change. So it's quite an overwhelming information gathering process, which can be stressful for the clients. And so Christians Against Poverty just wondered whether all of this information was actually helpful for determining a client's route. Would they be able to predict the client's route based on their intake data, and what intake data is actually relevant for that? So we worked with them, and some volunteers built a model to try to predict the client's route based on the intake data. And happily, these models, although kind of just a work in progress, they were able to predict the route about 90% of the time with only a few pieces of information. So this graph is showing how the amount of information or features affects the accuracy of the predictions in the model. So the number of features is the number of information provided. So total amount of debt might be one feature. And then the vertical axis is the accuracy score. So the maximum value would be 1, which means that it's right 100% of the time. And with only 3 pieces of intake information, this model correctly predicted the client's route nearly 75% of the time. And with 8 pieces, the accuracy was up to 80%. So knowing this, the CAP team can now think about what pieces of information are easiest for the clients to provide and optimize, what the accuracy of that recommendation versus the amount of information that the clients actually have to give to their advisor. All right, so this is the bit where please throw some questions in the chat if you haven't already, but I just wanted to spend a few slides demystifying some jargon and answering some common questions that we get asked. So some of the questions we get asked is, are AI or artificial intelligence, machine learning, data science, are they all the same thing? What's the difference between data science and data analysis? Are they all the same thing? And, perhaps to a certain extent, it doesn't really matter, but we just wanted to kind of clarify some common terms for you. So artificial intelligence or AI is a really big research field, very broadly aims to build systems or machines that can think or act like humans. And people have very different ambitions within this very broad field. Some people are working on systems that can perform a single task. So systems like Siri or Google Assistant, or you might have seen AI systems that are very, very good at playing chess. But then on the other end, people are trying to develop machines that are kind of indistinguishable from humans, and ways of assessing whether they are in fact indistinguishable. So artificial intelligence is very, very broad. Within that, machine learning is a subset of AI, and it involves trying to get a computer to do something without being explicitly told how to do it. So normally, computers are programmed to do things by a programmer. Machine learning involves building systems or programs that can learn from data to make predictions on new data that it hasn't even seen. So I think, as I alluded to earlier, an example of this would be something like Siri or Google Assistant. It hasn't heard every possible sentence in the human language. It's being what we would say trained on a subset of possible sentences, and yet it can understand most of the time your questions. So machine learning is basically building out systems or programs that can predict or learn, make insights on novel data that it hasn't actually seen before. Data science, as we described above, is the use of analytical and computational tools to get meaning from novel data sources. Sometimes this will involve machine learning, but sometimes you don't need all of that. And data science can include data processing, cleaning, data visualization, and data analytics. So data analytics, in my view anyway, is again, a kind of subset of data science. And this involves getting insights from historical data that you already have. So data analysts are usually trying to describe what has happened or what is currently happening, whereas in data science, a lot of what a data scientist might be trying to do is trying to predict what will happen. And that's where it tends to overlap with machine learning. So lastly, I just wanted to touch on how to get started. And Giselle will be talking about this in more depth on Wednesday, but wanted to give you at least one thing to get going with. And that is actually to forget about the data. The most important thing, I think, is to think about the problem. So as I said earlier, we're not looking for data, like a really beautiful data set. We're looking for a really beautiful question. And this can be really challenging. It involves looking at your strategic priorities and thinking about what are some of the barriers that you're facing. And one tool that I think is really useful framework is this 4-step approach from Eddie Copeland, who used to be at Nesta, thinking about, can I address this problem with data? And also kind of, should I? So this is a bit of an iterative process, but you might start asking, what problem or question would you like to solve? Related to that, like, what would you do differently if you had this information? We often ask people to reflect on what information, if only you had it, would make your lives much easier. Like, what information do you need to make a decision? What would you do with that information? It can be helpful to think as well about what you would need to see in order for you to have the information to make a certain action. And only then can you start thinking about, do you have that data? Or if you don't, can you get it? And so I think this can be a really helpful framework. And I think that definitely the most important thing in the data science process is to start with the problem and work from there. So with that, I would just say thank you and happy to take any questions.
Fab. It looks like we've got some great ones popping up in the Q&A. So thank you for adding them. There's also, if you haven't done this yet, little upvote buttons. If you do like anyone else's, click on the thumbs. I feel like you will particularly enjoy this first one, Darcy. Is there a threshold of data needed in order to be able to successfully predict trends / behavior, etc. from Ali Hunbury?
So yes, there's a threshold. What that threshold is hard to answer in a one-size-fits-all approach. So it depends a little bit what you're trying to predict. Very generally, the more things you're trying to predict, or the more, say, categories you're trying to label something as, like if you're trying to divide things into one of 10 categories, the more data you're going to need. So yes, there's a threshold. You generally don't want to try to predict things, say, on like 10 users, but it doesn't have to be 10 million. It's a bit of a vague answer, but yeah. And I mean, more data is generally useful, but more data often can just allow you to detect smaller things, and those smaller things aren't necessarily relevant. So you don't need to necessarily have a giant data set.
And some specific stuff here are Python and R libraries. One next question from Graham Murdoch. So for those who are newer to data science, so Python and R are two open source languages, which essentially means that you download a program that's free, and then you can just stick in commands. So it's kind of like Excel formula, but we'd like to think niftier because everyone's biased towards the tools they use. And it's open source essentially means free, but it also means that people can innovate really well. So that it means you get these things called packages, which essentially is like an additional bit of software someone's made with this language. That means you don't have to start from scratch, and instead you can use something that they've done. So Python and R, if you are wanting to get into data science, I'd say that they're really a recommended route, just because they're so powerful, so cost effective, and they've got great communities. That's the other thing about open source means community. I wouldn't tell you which one is better because Dulcie and I sit on the opposite sides of the fence here, but both of them are really good. Dulcie, do you have any? I mean, it's probably quite a tough question. Any thing you'd recommend for predictive analytics in terms of Python and R libraries? That might be tough.
If you have any for Python, so I both are great. I just am rustier at Python. That's all. So Python, like the big one is scikit-learn for kind of predictive analysis. If there's any Python experts here, feel free to throw your other favorite ones in the chat. For R, the carrot, not like the vegetable, but like the diamond package is quite popular. If you use R, I'd also really recommend tidy models and Broom, which allow you to basically run multiple models simultaneously, kind of in parallel. So those would be two packages that are good. And I would also just say on the Python and R thing, the thing that people don't tell you is that at least 50%, I think, of the data scientists that I've met are like self-taught in these tools. So don't be intimidated. Yeah, you can learn it. You don't have to have some sort of special degree or talent. Like you can, all of the kind of content and courses are open source and freely available. So just get out there and play.
But that's not to say that we wouldn't back you to try and convince your boss to give you a lot of time to do that. And money, because there are great courses you can pay for as well. But don't let that be too much of a barrier. And perhaps the kind of flip side of what we call like languages, so things like Python and R, where you're coding, are like low code and no code tools. So things where there might be more plug and play. And I'm looking at this question from Rima Sodher, and I don't know if you mean when you say tools and that can be utilized to perform predictive analysis. I don't know if you mean low code or no code, but it's a good segue because it's kind of, we've talked about Python and R, so maybe on the flip side, Dulcie, I know our world is a bit more codey than low code and no code tools, but do you have any tools that could be used to do predictive analytics that don't involve code?
That's a good question. I'm trying to think of in my mind. I think so there are tools out there that you have to pay for that will help you with these sorts of things. One that I've seen, I think might be free, that we've used quite a bit in some of our data dives is RapidMiner. I think it's not exactly no code, but it's a bit more drag and drop, and it's used commonly to often in sales, but it works in charities as well, to try to look at what are called association rules. So if this happens, what's the next likely thing to happen? So if a customer buys an apple, are they likely to buy an orange? But in charity world, you might say if a client comes in with a question around their housing status, are they likely to then come in with a question around their employability? So that's one that I think is a bit more drag and drop. But if anyone else has any more low-code predictive analytics tools, Giselle, do you have any to mind?
No, I don't think that I do. I mean, there's a lot you can pay quite a lot. You can end up paying quite a lot of money for things that aren't particularly good, which I think is part of the reason why. Well, it's part of the reason why we tend to go more for languages and kind of DIY than for ready-made tools. I guess the other thing in terms of data kind in our work is we have an army of data scientists. So for us, the people we get for free, but the expensive packages and software that we don't. So we kind of tend to make it ourselves. I'm keen to get some of these other questions in. Mary Maloney has asked a great one that comes up loads. How reliable is data science techniques with qualitative information? So, and I don't know, maybe if we want to start with just a qual versus quant, or did we say that already?
I don't know if we talked about that already. So like qualitative data versus quantitative data. So quantitative data is kind of numerical data. So counts of things, values of things, percentages, numbers. Whereas qualitative data might be things like text, like free text, or it could even be a video or audio, that kind of thing, a personal account. In terms of reliable, that's a tricky question. I would say there's a lot that you can get out of qualitative data with data science techniques, but I think with quantitative data analysis, you do need to kind of sense check it. So data science techniques can be very useful for obtaining quantitative data from qualitative data. So for example, if you have a whole bunch of text data, it can be quite easy to count the frequencies of different words and turn that text data into something more numeric. You can also do things like try to figure out common topics that people are talking about, for example, but you definitely need to sense check it. I'm actually going to put in the chat as well a really nice article about how social sector can use text data and data science as well, which might be interesting to you, Mary, especially.
I'm just noting in the chat we've had some suggestions from others. So Ian Ansel says TensorFlow, or am I going to say this right? Keras?
Yeah, yeah.
Is it getting thumbs up from Darcy too? Mark Sellers says if you're an R user, check out Tidy Models. Amit pointing out Power BI does have a bit of kind of clustering power. So a good place to start, but not necessarily kind of an even start. Actually, it might take you a bunch of the way. And then Darcy's posted that link from some DataKind US examples of using text. Looking at our questions, we've got probably time for a few more. A toughie but a goodie from Sarah Getgood. What further learning resources do you recommend? Are there any third sector specific examples that you know of? Examples of resources. I'm interpreting. Yeah, well, loads is probably the answer. And I think it depends a bit what you're wanting to learn. But Dulcie, is anything coming to mind that you start with?
Yes, I'm not sure if you're looking for specific third sector resources. I would actually suggest checking out the third sector folks who do some specific training on data tools. DataWise London also do charity specific and social sector specific data training. In terms of general kind of learning resources, I am a fan of the kind of free online courses. I like Coursera, for example. I'm going to try and put these in the chat. I've also would recommend DataQuest if you're looking to get started. It depends, exactly what you're trying to learn. If I'm going to plug our expo booth. If you do want to come and chat this through, just drop by there and I can try to find something more specific if you have a particular question.
And I'd say Ian's made a good point in the chat of previous data dives. So one type of support DataKind offers is a data dive, and we tend to, if our partner charities are okay with it, we tend to try and write them up and share their examples. So if you're looking for kind of inspiration and other journeys organisations have been through, then definitely check them out on the datakind.org.uk website. So that's a bit of a plug from learning from us. But probably the other thing to say, if you are learning out, is that we have something called the Social Data Society, which is a group of technical folk in charities and other social change organisations who meet every 6 weeks and discuss their shared challenges, shared areas of kind of future aspiration, so things that we all want to learn about, and also act as a kind of peer support community. Actually, a few of the folk that have been putting comments in the chat are part of SDF. Hello, and it would be lovely to have you along. If that sounds like something you want to get involved with, we don't have any high-tech stuff online for it. We kind of keep it a bit quiet. Probably the best way is to, I think there's about 250 people on this talk, so I guess keeping it quiet is maybe not going to work when I say things like that. But probably the best thing to do is, dare I say, Dulcie, sorry for your inbox, but email Dulcie if you want to become part of that community. And then finally, the other thing in terms of communities for data folk is the Data Collective. So Dulcie, can I charge you with finding that link and sharing it in the chat as well? So whereas the Social Data Society is quite a technical group, if you're kind of a bit data adjacent, I suppose, rather than wanting to get particularly technical yourselves, then I'd say join the Data Collective. It's a much broader church of folks, but same end goal, to prioritise and promote good data use in the social sector. So what else? Do we have time maybe for one more question? We've got two voters. So we have Cam Technav. For prescriptive analytics, how do you go about finding what goals you're aiming for, as in what to try and prescribe? It feels potentially very broad. And then we'll take this as a two. Victoria Hurst, thanks very much for this talk, really helpful. Thanks. What programs, approaches do you recommend using to carry out data segmentation? So, Dulcie, we've got 2 minutes. Perhaps we could do a whirlwind on those two.
Okay, data segmentation, unfortunately, I have to come back to Python and R in terms of classifying users. But there was one of our wonderful volunteers recommended something else to me. So I'm going to dig that up and I'll ping you or I'll put it in the event chat, because there are no code tools. And in terms of how do you find out the goal for what you're aiming for? I mean, I think that gets to a bigger question around what impact are you trying to achieve. So I think maybe go back to thinking about your organization's like theory of change, if you have one, thinking about the outcomes that you're trying to get to, and then think about what sorts of results you would need to see in order to evidence that you're meeting those outcomes. Giselle, any other thoughts on that one? It's a tricky one to answer.
Yeah, I think it is essentially, I'll highlight what you say, underline what you say. I think it is a organizational question as much as it's a data question. So I suspect if you did the kind of thinking within the organization to come up with the answer to that question, and then kind of said, well, is this data scienceable, to completely mess up the English language, then I suspect you're more likely to say, yes, it is, let's go for it, than if you do it the other way and say, okay, what can we predict? Right, let's do a bunch of that and see what's useful to the organization. I think getting something that's useful for the organization is going to be less likely the case that way. So yeah, probably a more non-technical question than a technical one. Okay, it's 35 past, so I want everyone to be able to have a bit of a comfort break before our next sessions start at 22. So I think we're going to say goodbye. Thank you so much, Dulcie, for the time. It was, from my perspective, really enjoyable. I hope you agree too. If you do want to talk a bit more, just come to our booth, or get in touch. All our emails are on our website, or DM us on here, and hopefully we can talk more over the next couple of days. Okay, bye all.